Welcome. In this one, we're going to derive the formula for the volume of a sphere by using the disk method from one variable calculus. So we're going to begin by assuming that we have a function that looks like f of x equals the square root of r squared minus x squared. Let's go over a little bit what this actually means. So first of all, notice that in front of the square root is really a positive sign. So when you graph this, it looks like the following here, okay? Going to have basically a semicircle. And then the r here, that represents the radius of it. So for example, specifically down here, it's little r. Up there is also r. And then over here, it's also r right here, negative r specifically. So to make a sphere out of this, you would take this semicircle and basically rotate it around the x-axis, and it would make a sphere. So we can use the disk method to actually find the volume generated by rotating the semicircle around or about the x-axis. Let's carry that out. So let's remind ourselves, first of all, that here's the general concept for the disk method. So you have the integral from a to b of pi f of x squared dx, and then let's actually apply it to the specific function that will give us the volume. So here, I'm going to proceed as follows. Let's set up the integral. So I'm going to have the following integral here. Negative r to r. So that's so because on the left side it's negative r, on the right side it's positive r. So the integral limits are negative r to r. The pi stays. Then I replace f of x with this quantity, square root of r squared minus x squared. Don't forget up here to put a 2 up there. So now, the next stage in this process would basically to be canceled the 2 and the square root symbol because they're inverse operations. And also, you want to make use of symmetry as much as possible. So what is that telling us? Look back here. What it's telling us is the following, is that this piece on this side where I'm kind of located is the same as this piece on that side where I'm located now. So I can just integrate instead from 0 to r along the x-axis and then just double that result, and that's using symmetry, so I don't have to deal with negative r as the lower limit of integration. So I'm going to proceed as follows here. I'm going to replace that integral from above with this one. So now the lower limit of integration is 0. Out here there's a 2, again, so using symmetry, and then now I have r squared minus x squared as part of the integrand. Now we just have to go through the terms and essentially differentiate. And notice that the pi is a constant, so if you like, you can just place it outside together with the 2. So I'm going to proceed as follows. I will type 2 pi on the outside. Now when you integrate r squared, it's going to give you down below r squared times x. And when you integrate x squared, it's going to give you down below here negative 1/3 x cubed. And then you're going to stick in the limits of integration. Well, those look like this. You're going to have an r up top and a 0 down below. Now you just have to plug them in and simplify everything. So that's going to look like the following. Well, first, I'm just going to copy the 2 pi. Then I'm going to put r squared times r minus 1/3 r cubed. So notice that for this step right here next to me, every occurrence of x has been replaced with r, the upper limit of integration. And then from that, you're going to subtract, naturally enough. So it's going to look like minus, and then every occurrence of x will be replaced with 0. So it becomes r squared times 0 minus 1/3 of 0 cubed. Let's continue. All of these terms under me that have 0 will vanish, which means across the top now where I'm picking up, it's going to look like this. It's going to be 2 pi and then r squared times r minus 1/3 r cubed. Then you can multiply, well, r squared times r over here, that's going to give us this, r cubed. The negative 1/3 r cubed stays for now. The 2 pi as a constant stays for now. Now r cubed minus 1/3 r cubed, we have to work that value out. That's going to look like the following. We write r cubed as 3/3 of r cubed minus 1/3 r cubed. Why would I do that? Because then the fractions have the same denominators and I can subtract easily. So it's going to look like this now. 3/3 minus 1/3 is 2/3. Copy the r cubed. Lastly, this 2 right here can be multiplied by the 2 and the 2/3. And when you do that, you end up with the following value. At the end, you would have, as the formula essentially, 4/3 pi r cubed. And this is the formula we've been looking for. Thanks so much for watching. Please leave a like and subscribe, and I'll see you in another video.